here also. So yeah, so I'm seeing it has a countdown of 1 minute and 15 seconds or something, going up, down. So going up, down. So yeah, okay, that's better. Cool. So I think we're good now. Okay, cool, awesome. Now we are live. Okay, so as guys are joining, I'm looking at the live stream and I'm seeing guys are joining slowly by slowly. So just as that is happening, just as a few reminders for everyone who's going to join us, is we're going to post the questions for the questions that you may have even as the session is going on. So if you have any questions, please just take some time, note them there. You can note them on the chat, you can note them on the link that you're going to provide, even as the session is going to continue. And yeah, I guess just feel free to ask any questions. We have an amazing team here. So some of those questions that probably you have thrown at maybe Alela, Juma, myself, Marvin, name it. I think these are the best people to answer these questions. And so as people are joining, I think we probably can start off with just like a basic introduction. I know like Chet is not here, Chet is going to join us later. And so for everyone who is joining us right now, welcome to today's Android 11 meetup session. It's happening online, obviously. And we're really excited to have an amazing team of, I think the right word we should use here is brilliant, guys, and it's fantastic that they've taken their time out to be here with us, and they're joining us all the way from, wow, so far away. So I think let me give them a chance to just like introduce themselves and say what they do at Google, and then I guess you can start off with Murat. So Yacine, we'll start with Fred, and then Yacine, and then Murat. You will just introduce yourself, and then you continue. That's cool. Awesome.
Cool. Hey, everyone. My name is Fred Chang. I'm with the Android Developer Relations team. Thank you for having us today. We're excited to be hosting an Android 11 meetup event with the community in Nairobi. My understanding is the joint event between GDG and Android community. So I personally am involved with Android framework platform, that sort of stuff in the privacy area. So I'll be joining today's session in the Q&A part. Yacine?
Hi, everyone. My name is Yacine Rezgi, and I'm an Android developer advocate at Google in London. Today, we'll be talking about privacy on Android 11, but still happy to answer any question related to Android Studio. And I know there are a lot already, as well as Jetpack Compose and overall on Android development. So feel free to ask us any question after all our sessions.
And I guess that's me. Hi, I'm Murat, a developer advocate for Android. And today, I'll be talking about what's new in Android. I work with all the people who introduced them before. And I really wish I could be there in person, but who am I kidding? The farthest place I went from home since March is the supermarket, which is 2 blocks away. So we'll see. Enough chit chat. Let's start with what's new in Android. To start with, of course, Android 11. Well, it's still in beta, but this basically means we promise you that the APIs are stable now. They're not going to change. So you can go ahead, test your app, adapt to changes, as well as integrating the new features before the final release. I will also talk about the new tool capabilities and libraries, which are not really bundled with Android 11, but recently released. So, of course, when we talk about changes, the most visible changes for us and the users is UI. First, let's start with Window Insets API. So traditionally, we give you information about geometry changes that happen on the device screen, but information we provided through the APIs was not perfect, and it wasn't helpful all the time. With the new APIs, you get more detailed info on what's really happening, whether it's the status bar or the keyboard. Most of the old APIs, which didn't give you enough information, are deprecated, and the new APIs give you more detailed information on the window and the current situation the device is in. Let's take a look at some code. Here we have the listener that gets the window insets information, and with that, you can query whether a window is visible, like the keyboard in this case. And this is something you couldn't do before. And you can get the insights for that specific window and decide what to do next. Well, you might be asking why this change is happening now. Well, the big reason for this is actually IME animations. With IME animations, you can synchronize the motion of the app UI with the motion of the keyboard. Again, this was not possible before, and we have been working on this in the last few releases, and finally it's here. You can do two things here. First, you can listen for changes that are happening to the keyboard and react accordingly frame by frame. You can move your views or scroll your content off screen depending on how you want to react to the keyboard. Or you can prefer to drive the keyboard animation manually. We'll see all in detail. But let's see some the behavior visually first. On the left side, you see the traditional keyboard animation where the keyboard pops in, and with Android 11, you can animate your UI with the move of the keyboard. Previously, you didn't have this opportunity since the system only told you that the insets have been changed only after the keyboard become visible. With this new API, you will be notified as the keyboard animation starts, and you have the opportunity to react smoothly. On the right, you see the other approach where you can control the to drive the animation of the keyboard. Here in this animation, you see the user is pulling that content up, and as they do, you can move the keyboard up. Again, let's see some code. Here we have the keyboard animated by the system, and what happens is that the animation callback tells you where in the animation lifecycle you are, so you can control your app UI according to that. For the second option, where you want to control the animation, you can drive the animation as the user moves the content up. So here you set the animation on the window type of the IME, set the duration, which is infinite in this case, since it depends on the user. Set linear interpolator, since you want a linear motion, not like something speeding up. And cancellation signal to allow you to cancel the animation along the way. And the lifecycle listener to see if the animation is complete or canceled or maybe just starting. To learn more about window insets and IME animations, check out these links for the sample app. All the screenshots I showed you are from this app, so go check out the code to learn more about IME animations. With that, the next topic is conversations. Well, if you take a look at what you're doing with your phone, it's mostly around people you know. Whether they are your friends, family, or maybe colleagues, you constantly interact with different people, sending them texts, emails, chats, and so on. One common thing about these interactions is that they spread through time. They are continuous conversations. One way or other, you get back to the conversation and pick up where you left before. And once again, we wanted to make this easier and seamless. With conversations, if you have an ongoing interaction in an app with someone, the notification for that specific interaction will have a dedicated area in the notification panel. This gives you the opportunity to customize settings like how you get notified or change the prioritization with a simple long press on the notification. But again, let's see some code. First, you need to create a person to have the person information. Conversations require a long-lived shortcut, so you create a long-lived shortcut. You set the shortcut you created to Shortcut Manager compat as push dynamic shortcut. Next, you must use the messaging style and set the person you created to that messaging style. And finally, build the notification with the shortcut info from before, just like you would build a notification before. Next, we have bubbles. Well, you might be asking, didn't we have bubbles already? Which I'll come to that in the next slide. But simply, bubbles are surfaces bubbles surfaces conversations over the entire UI and make them reachable from anywhere, anytime. Bubbles are built on Notifications API, and you need very little change to implement it. Bubbles was a developer option in Android 10, and with Android 11, it's available. As I mentioned before, you might be asking, didn't we have bubbles already? The previous bubble implementations you see in apps used an API called System Alert Window, which was not specifically designed for creating bubbles. It was not super easy to use and had capabilities more than necessary for just displaying a bubble. As I mentioned, it's built on the Notifications API, which means you create the notification just like before, but add some metadata, and you need to have a dedicated activity to handle the bubbling. Let's see some code. To start with, we need a dedicated resizable activity. This activity needs to be resizable because it can be shown in different sizes. This activity will be launched when the user taps the bubble. And again, you need to use shortcut info to create the bubble data. Then you need to use this metadata when you're creating your notification. Notifications can only bubble if you set this shortcut and use messaging style, just like I mentioned in the conversations. If you follow the link on screen, you can check out the code sample for conversations and bubbles. Also, you can listen to the ADB podcast episode 140 and 141 to learn more about bubbles and conversations directly from the engineers on those teams. Next topic, privacy. And ironically, I'm not allowed to talk about it because next talk, Yacine will tell you more about privacy in detail. Yet, I'll give you a very, very, very brief info just in case anyone plans to leave after this talk. So start with, privacy is something we've been working to improve in the last several releases, and Android 11 is not an exception. One new thing about privacy, we have a new API called data access auditing. Accessing private data and resources is something sensitive, and sometimes it's hard to follow which part of your app is doing that. The new data access auditing API allows you to get notified when some part of your app accesses the sensitive data. Another change is, and probably the most visible one on privacy, is one-time permissions. Well, you might want to temporarily give permission to an app, such as reading your credit card with the camera, but this will be something you will be doing only once, or maybe once again when you have a new credit card. So with one-time permissions, you can temporarily give permissions to an app, which will only live through the while the app is on. Besides this, there are a few other changes to the package manager, which restricts apps to query other apps, scope storage, which we introduced in actually Android 10, and finally auto-reset permissions. Again, if you want to learn more about those, make sure you watch the next talk where Yacine will walk through every change in detail. And if you're not interested, then go hang around until Chet's talk. But enough about APIs. Let's see some behavior and also behavior changes. Let's see some developer goodies. Let's talk about features which help you to develop apps. We've been trying to ease the developer pain and fix the problem points. And to start, there is something I'm really excited about: Wi-Fi debugging. I remember debugging my first Android Wear device over Bluetooth long years ago, and since that day I've been dreaming about this. To be honest, actually, the situation is even worse now. Today we have less USB ports, more peripherals, and different type of USB ports, as well as different type of cables. You might easily run out of free USB ports or pick a wrong USB cable when you're leaving the house, so you end up not being able to connect your device to your laptop. And actually, this image is an actual image from our office, well, when we had an office or we were allowed to go to office. This is a new feature, and it's not in the tools yet. You must enable it on the device and then use command line to connect and pair with the device over Wi-Fi. Unless you're using Canary version of Android Studio, then things are a little simpler, which I'll talk about later. Next, we have nullability annotations. We all know Java has null values as default, and Kotlin does not. And even though you built your app with Kotlin, the platform APIs are in the Java programming language. So in order to take full advantage of Kotlin, we are annotating the platform APIs. First, we have recently nullable and recently non-nullable, which basically tells this method or parameter will not be a value of null. Well, you might be thinking, isn't that what nullable and non-null annotations do? There is a subtle difference. Recently annotations will create warnings during compile time if you use null values on them, which gives you a chance to fix your code without breaking your build. We all know what happens when you break the build. It's everyone in the team receives an automated build system email telling you break the build. So this won't happen. Well, this doesn't mean you should ignore this warning, as we might convert recently annotations to nullable and non-null with the new platform releases. But it gives you some time to test and see if your app is compatible with that. Well, no matter how much you test your app, crashes happen in the wild, and it's really hard to figure out what might be wrong since you don't have access to user devices. To help you with this, we added a new API that helps you to see why your app has crashed. One super fun thing about this is actually it's super cool. It automatically uploads everything, and you can query the crash reports reasons over the historical process exit reasons method later. You can iterate over the list of reasons to see if it was a low memory or null pointer or maybe a native crash, and you can fix the issue. You can use this API directly, and even if you're using another crash reporting service, you can still use this API to gather more detailed information about the crash. Next, we have GWP-ASAN. GWP-ASAN is a great tool to gather information from real user devices. GWP-ASAN is actually an improvement over HW-ASAN, which was released on Android 10 and helps you gather information about memory issues for native developers. The main drawback for HW-ASAN was that it was only available while you were debugging your app. With GWP-ASAN, now you can debug memory issues in real user devices. GWP-ASAN does add GWP-ASAN does this with adding a very lightweight layer to memory allocation calls and captures the problem so you can later go through them and see what might be wrong. It has very little overhead, both for the runtime and memory. And the best is, again, the reports are automatically uploaded to your Play console, which you can go and check later. To enable GWP-ASAN, you need a flag in your manifest. You need to set the GWP-ASAN mode always. Here I'm enabling it on application level, but you can also use GWP-ASAN at any activity level, so you can opt in and opt out any activity you want. And if a crash happens in your app or activity, which you opted in to GWP-ASAN, the log is automatically uploaded, so you can check out what might be wrong. Next, ADB incremental for faster installs. Let's say you have a large APK, such as a game, and every time you fix something, the whole app needs to be rebuilt and redeployed to your app, to your device. With ADB incremental, now it's possible to incrementally install only the change parts and go up to 10 times faster in a large app. One thing to note, this might not be super noticeable in small apps, but as your app size grows significantly large, you can really benefit from this, such as not installing all the game assets each time you do a small change, like adding a new constant or string. Just like Wi-Fi debugging, you need to do this. You need to enable ADB incremental through command line. If you add incremental flag to ADB install, and you will get faster install times in larger apps. Well, Android 11 introduced a lot of behavior changes, and you need to test and see how your app reacts to those changes. The good news is most of these changes I talked about, or Yacine will talk about, are limited to target SDK-R, which means it gives you the opportunity to not change your build targets to R and use that time to finish making the changes and adapting to these behavior changes. But also, you need to test these behavior changes. We have behavior toggles, which you can turn on or off specific behavior. You can do this through the command line or things we have done or the new developer options panel. For each behavior, you can use the toggle to switch on or off a specific change. And if you prefer to use the command line option, this is the command you need to use. You can use the compat enable or disable flag to turn on or off a specific feature, which is default scope storage in this sample. With that, let's see what's new with graphics and media. This actually is something interesting. All the image decoders, whether it's JPEG, GIF, PNG, are all actually in native code. And we use Skia library, but these APIs were not actually exposed to native code. So what happened was, if you needed to call these from native code, you first call the Java API through JNI wrappers, which basically means you were using JNI to call native code from native code. Now all these image decoders are available from native code, so no more you need to do JNI calls or bundle third-party libraries, which will increase your APK size. Let's see some code. First, you need to create a decoder from the asset, set up a targeted image format for decoder, allocate some buffer to hold the decoded image, and decode the image into that memory buffer. This code is actually from the image decoder example in NDK samples, which you can find the link below the slides. Next, animated HIF files. Animated HIF files, as the name suggests, is very similar to animated GIF files. If the HIF file consists of images, it's treated as an animated image drawable. As I mentioned, they're pretty much like animated GIF files, but smaller in size. To use animated HIF files, first you need to create a file from the source and create the image decoder from the file. Then use the image decoder, of course, not in the UI thread, to get a drawable. Anytime you can call the start method on this drawable to start playing the animation. If you're into audio, there is a chance you've been using OpenSLES, which is now deprecated. We've released a new open source library called Oboe. This is an unbundled, high-performance, low-latency audio library, which works back to API level 16. You can check out the code on GitHub, and if you're into audio, listen to the ADB podcast to learn more from the engineering team in episode 135. Next, variable refresh rate. Refresh rate is an interesting topic. Until recent years, almost all the devices had 60 frames per second displays, which meant your app has roughly 16 milliseconds to finish updates. Today, we have devices running 90 or even 120 FPS, which leaves even less time for apps to finish their updates. If your app controls its own rendering loop, such as a game or similar, you can take advantage of choosing your own desired refresh rate. If your app cannot finish what it does in the default refresh rate, it's automatically dropped to half. And in many cases, you can actually do something better by setting your own backup rate. For example, instead of dropping to 60 frames per second, because your app cannot catch up with 120, you can instead drop to 90 to see if you can catch up with that. And if you do, you can still offer a much smoother experience. To do this, you can simply call set frame rate, and keep in mind this: the system still decides which frame rate is best. So this is a request, but it's not a guarantee. Next, we have Thermal API for NDK, because we already had it for SDK developers for a while. Now on, NDK developers don't need to use JNI to call the Thermal API through Java APIs. If you have a high-performance app, such as a game, you can make use of the NDK Thermal API to directly respond the device's current thermal status. You might lower the frame rate or do less calculations until the device recovers from high temperature. And again, you can do this without using any JNI wrappers. Let's see how we use the API. To use the API, you first need to add a listener for status changes and then react to current device status. Well, probably you're out of options already if the device is shutting down, but you can save resources and maybe put some functionality to idle if you're in a less critical state. And of course, the best is thermal status none, which means you can use all the resources the device offers and run at full speed. Well, of course, to subscribe to thermal status changes, you need to register the listener to Android's a thermal manager object and then continue running the app or game and listen for changes. One thing to note, don't forget to unregister your listener when you're done with the app and listening to status. Well, this is not all. Neural Network API version 1.3 offers new capabilities such as new operations, new quantization scheme, and advanced execution control. 5G is coming, which offers super high bandwidth and low latency, but you may want to control and limit the bandwidth your app is using, such as if the user is in a metered network state. So we have APIs for those, and if we look at some code, the new APIs let you check network capabilities and decide on how much bandwidth you want to use. So you can help your users to have better 5G experience. Just like refresh rates, once we only had passwords and PIN codes to authenticate ourselves to our devices. But today we have so many different ways to authenticate with devices. And of course, not all these authenticators have similar strength. For example, 2D face unlock is not as secure as 3D face authentication. And your app may even find 3D face authenticator maybe not strong enough, like fingerprint or password, depending on your use case. Wouldn't it be wonderful if you could control the authenticator's strength and ask for another authenticator if the current one doesn't match your requirements? And actually, you can do all these with the new Biometric API. You can ask for a specific authentication strength required by your app, and then check if that matches your requirements to decide to authenticate the user or ask for a password or another way to authenticate. Autofill and keyboard integration. Well, I'm pretty sure you're all familiar with keyboard suggestions. Take Google Keyboard, for instance, which suggests both right spelling of what you're typing, but also address or payment info as you fill out. So what here is basically a way that you can populate autofill suggestions. If you're building a keyboard app, you can opt into this to get answers. Or if you have an app such as a password manager, you can add your own suggestions, content to the keyboard. Of course, these all happen in a secure way. It's not like passing the plain content itself, but passing the data reference, which can be accessed in a secured way from the consumer. Here we see the Google Keyboard app, where the autofill suggests email, credit card info, or postal address sign in. You create a suggestion request, and then you set. If you want to provide suggestions, such as if you're a password like on field request, visual and create a field response with a data set, which the system will pass to the keyboard to provide suggestions. Finally, and actually some of the previous stuff I mentioned were not type 2, but every 2 weeks, if we first we have full power of Dagger, but makes it much easier to use without any setup. Since Camera X has been around for a while, and now it's in beta. Use of all the device-specific features and more. Next, we have Jetpack Compose, which is the new UI toolkit for Android. It's developed in open, so it's the best time you can, which you can check out the samples and code, give feedback, and follow the which I'm sure you're all very excited about. 4.0 comes with motion editor, which makes with XML code. Another tool released in 4.0 is and can directly take you to the Android Studio 4.1 is in beta and has a very exciting tool called Database Inspector. Sheet. Wrote a blog post on this, and believe me, most of the feedback is, well, this was the tool everyone since all the 4.2 is in Canary now. 4.2 comes with the wireless debugging, which I mentioned before, and also with a new Jetpack Compose. But to download Android Studio 4.2. And for Android game, and now it's simpler and easier. There is a dedicated and for much info on Android 11. If you don't find the talks today enough, you can go out and check all the launch videos, which dive into detail on every specific topic. 11 weeks of Android hosted a different topic with new content each week. It's approaching to the end, but all the videos and other content is available for you to check out. So go find something you're interested in and check out what has happened that week. Another thing which is happening is Android 11 apps. I guess you're already familiar with this since you're already watching one, but it's a other events. We're all watching it online, but yeah, you can go out and check other events. Finally, it's hard to follow everything happening in Android world, and to help with this, Chet collects from all the links and info in article, video, and podcast form, whichever you prefer. And with this, I guess I'll wait to the end to answer questions, but I can pass the mic to Yacine.
All right, everyone. Times for me to present. Murat, can you just turn off the presenting on your side?
Sure.
Perfect.
I told you I'm passing the mic, not the screen.
Let me share my screen. And here we go. All right. So hi, everyone. For the ones who didn't join us earlier, Murat just presented what's new in Android 11. And now me, Yacine Razki, I will present to you what are the privacy changes on Android 11. For any questions, please wait at the end. My colleague Chet will have another session, which is really interesting as well, and we'll be answering all your questions. And for now, let's focus on privacy. So the first thing to know is Android has always had a focus on privacy, but it has been way more visible in the recent versions. And Android 10 was a really known one for that. And Android 11 is pursuing that goal of making a really private device for the users and giving them the control over their applications as well as their data. So here, what we're trying to achieve for developers is flexibility in terms of APIs, as well as more control, more transparency for the users. On Android 10, we made some changes on the platform to highlight that. And now with Android 11, we're bringing further permission changes, as well as updates on scope storage, new foreground service types, package visibility. It's really important. I will go more in details after that. And also data access auditing. So the first thing, let's talk about the one-time permission. So from what we saw, whenever a user have a choice to prefer to share less data, they always do that. It's not that they don't want to share, it's just they think it's better to restrict it to a specific piece of their own private data rather than a broad access. And we also saw that many applications were requesting background location access, but they didn't specifically need it. So based on users and developer feedback, in Android 11, we're bringing users more granular control over device private sensors, location, but also camera and microphone as well, and those significantly limiting access to background location. We're not removing, we're just putting more barrier to access it. It's just for more comfort for the users. So one big change there is user will be able to grant a one-time permission for location permission requests. The same also goes for the other private sensors that I mentioned. And it means that while your application is on the foreground, so the activity is visible to the user, or when it's a foreground service, you will be able to have access to those. But when it goes to background, or when the application is closed, you're losing that access. So it doesn't mean that there is no way to be able to access background specifically for location, because we know there are some genuine use case there. I will just, by default, we're trying to make it harder to access background location. It's here again just to give more control to the users, because we think it's important for them to be fully familiar of what kind of access they're giving to applications. And that goes for microphone as well. So imagine an application where a user can call the support, for example, but they don't really need most of the time, just whenever they call the support. The user can make a voice-only call, for example, and in that case, rather than granting access to the microphone all the time, they will be able to give access to the audio, so meaning recording the audio, only that specific time. Same thing for video. And you may have an important question as a developer is, do I have to change anything in my code? Well, nothing. Nothing in a sense. If you're following our current permission best practices, you don't have to change any of your code. What the permission best practices means. So first, let's see this example where a user can select an access to the location. By default, in your code, the right way to do it is whenever you need to access the location, but also the camera or the microphone, you should always check that permission is granted. The old way was to ask the permission one time and always assume you have it. But in the meantime, while the application is paused, when the application is closed, the user can deny that permission. And Murat mentioned earlier, we have the reset permissions, which is after a certain period of time, can be days, can be weeks, you should not assume a specific time. The system may deny access to a permission, not deny, but may remove that access, may remove that grant, because it means that the user is not using your application anymore. Again, doesn't change anything for you, because you should always check if you have it or not. And if you don't have it, you should check with the system if you should show the rationale to the user, meaning you need to explain to the user that they may need they need to have access to that permission because they will need to make a voice call, something like that. And in the case the user denied that request, deny that permission, you should just be able to show a snack bar or something else in the UI to mention to the user, I actually need that permission for this specific use case. You should not close your application or crash your application. You should always have a backup solution. So if it's the location that you need, you may allow the user to type their own address or their own zip code, for example. But here, if you still really need it, you should show to the user that you actually need that rather than keep asking until it's denied. The thing to know, and it's really important on Android 11, is whenever a permission is denied twice, you may not be able to get it directly. So you may not be able to have that dialog shown to the user anymore. They will have to go to the settings and grant that access. So be careful on not spam your user asking many times the same permission until they accept. You should show it only when you need it and provide some context before, like that they understand why they should give access or not. Also here, I showed you so far some code to deal with the permission. So having the on-request permission result, which is the common way and everyone is getting used to that. But we introduced with our recent release of Jetpack activity and fragments libraries, the activity result API, which is a much handier way to deal with that. I really encourage you to have you look at the activity result API to see how much code you have to write, which is way less than currently. So now to give user fine control, in Android 10, we split the permission between foreground and background location access. Applications are encouraged to incrementally request this permission to give users better control. First foreground, then all the time location access. So for a map application where you can check your usual public transport, you should ask for while the app is running first. And after that, if you want to provide, for example, some info or some notification, if a train is down, if a line is not working, you should ask that afterwards. So showing that there is actually a need rather than asking upfront for it. That was a recommendation in Android 10, but in Android 11, this pattern has become a requirement. So it means you can't ask for background location straight from the beginning. You should wait until you have first the foreground access. There's no change for foreground access requests, and this will be adequate for most use cases. On old version, this requests foreground access, and on pre-Android 10 version, background access is implied. So for background compatibility use case, we're giving you background access for for pre-Android 10 versions. But again, remember that you should always check before assuming you have that access. For background access, when you target Android R, there are two changes. First, it's good practice to incrementally request permission to give users a chance to understand and decide based on context, as I mentioned. So instead of asking for foreground and background together, you should only ask for background location after your application has been given foreground access. When your application requests background location permission, the request permission API will send user directly to the setting instead of the regular permission request dialog. So you know, it's to avoid them just saying yes too quickly because they have been used to just saying yes all the time. And it's good practice to educate the user before requesting the extra permission with some sort of explanation UI, for example. And make sure to provide the option for the user to refuse, since there is a rate limit, as I mentioned earlier, and after 2 refusals, you won't be able to show that dialog, and the user has to manually go to the settings and set and give you access to that permission. But for developers, there is no change of API also. There's a user experience change, but in terms of API, it's still the same as you have been used to so far. So to ensure compatibility, application targeting Android 10, so API level 29, is still allowed to request both foreground and background location permissions at the same time. An extended dialog is shown instead. So it's here just for you to understand how the behavior is done when targeting API. But you should not expect, of course, to always be able to target SDK 29. As you know, every year we update our target SDK requirement on the Google Play, so you should prepare to migrate. That gives you some buffer time, but don't wait the last moment. It's never a pleasant moment. So now let's talk about data access auditing, which is a new API we brought to help developers understanding which part of their code is accessing private data. So best practice for building mobile application is to ensure transparency for accessing private data. If you're accessing location, you should have a reason to access that. Same for voice, same for camera, same for any private data. So, for example, it should be clear and obvious that to the user why a voice application needs to access their contact information to call their friends, for example. And the challenges faced by developers is sometimes they have thousands of lines of code, if it's not 100, and for some of them it's even millions of lines of code, and it's hard to find which part of their code is accessing the location, the contacts, the microphone, or any private data on the user device. Sometimes it may also be part of some old code, so some code that no one manage and handle anymore. Some part may be provided by a private source SDK. So you're using an SDK from another company and you don't directly have access to the code of it. And sometimes it's just that you're accessing through a library, an open source library, but you didn't check all its code. And again, it's hard to know all of that up front. So as I mentioned, that orphan code or those dependencies are sometimes hard to check, to have a look inside, to inspect, and that end up having just so many connections to all of that private data. So what we brought is a callback on data access. So you will be able to set a callback, and whenever one of those private sensors or one of those private data API is getting accessed, we will call your callback first. And the second one is feature tagging. Is if you want to know precisely which part of your code is doing that, you can put a specific tag and upload that to your logging platform to be able to monitor that even after your application is deployed to your users. So how does that work? Whenever you're trying to access one of those APIs, you usually try to access them through the context, which is provided in your activity or your fragment. And we will be able to tag inside Android 11 devices any of those calls and be able to tag them if needed. So that API provides a mapping from your code to those private data API. How does that look? So first, we will set up our data access operation callback. So in your application or in your activity, if you want to nail down specifically, you can put val app ops manager, which is an instance of that system service. And your callback will be called again, as I mentioned, every time there is a synchronous or asynchronous access. For synchronous access, it means you're trying to access the location, for example, specifically at that time. Asynchronous, if you're doing anything related to geofencing, for example. And the tagging part is, there is, in an application, there are like some modules, some blocks of it. So one part may be the sign up, one part may be the navigation, the find friends feature, the explore nearby shopping, and more. So you will be able, with the tagging API, to say, well, this group of call on my context will be tagged with this specific string. Let's take find friends, for example. Rather than getting context in the way you are used to, like context if you're using Kotlin, or normally it's getActivity.context in the Java programming language. I've been so used to write that in Kotlin, which is way handier that I kind of forget, sorry there. But rather than getting the context directly, you will use the function create attribution context, which is the same thing. You're going to get the context and use the content resolver or any API you have been used to. But for those ones who are accessing private data, we will tag it and we'll say, hey, whenever there is a call, please call my callback to know which one, which part of my code has been needed this specific API. And you will be able to get back that tag in your callback through the attribution tag property. So again, here, it's really hard for big application or an application that use a lot of external dependencies, open source or not. And with this API on Android 11 and further, you will be able to monitor that. So in development, you can check on your computer, but after that, you can send those logs around private data access to your server or to your favorite service and be able to monitor that. So one use case would be to use Firebase logging platform, and we'll be able to monitor that afterwards, making sure that it's not only a development problem, it's also production, and helps you to be more transparent with your user. Now into foreground service types. So to provide better accountability for application accessing private data in the foreground service, we've added a couple of new foreground service types, microphone and camera. So on Android 10, we already brought sync, media player, phone call, location, media projection, and companion device. Whenever a foreground service type is one of those, you will have this active notification that can't be removed, like that it's clear to the user which API is getting used. And two of them were enforced, which is media projection and location. Now on Android 11, we're bringing further service types. First is the camera, and also the microphone, both if you target API level R, which is Android 11, you can declare them and access those APIs through foreground service types. The great thing there is it will be transparent to the user which application is using it. So whenever you're more transparent to the user, you're gaining more trust with them, which is always the best behavior we have on our platform. So I highly recommend you to update your target SDK and to use these new features. So as I mentioned, we already had location, and now you can have microphone and camera as well. And those are enforced. You must declare them in your manifest if you target Android 11 SDK. So now let's talk about package visibility. On Android 10 and earlier, this API, which is package manager.getInstallPackages, the default property parameter, is 0, allows you to access all the installed application on the device. And it was great to do a lot of custom integration. We know it's a core part of the developer experience on Android. And when you target Android 11, so the API level R, we made some changes, but for the most common scenario, you don't need that. You don't need to make any changes, which is great. But for some specific part to protect more the user privacy, we enforced and added new APIs there. So when you query the package managers, normally you will be able to interact with those applications. And again, in most cases, you don't need to do any changes. So for the interactions that are not affected is when you try to get your own package name, obviously, because you know you're already installed, you will have no problem getting those information at all. It will work as expected as previously. But if you try to get the installed packages by default without any changes, you will only have your application and the system packages, not the pre-installed application, only the system packages. And for some implicit intent, so trying to capture, sending the image capture intent and having that dialog coming to the user selecting which of the application installed that can handle capturing an image intent be launched, that won't need any change. It will work as previously. You will have the result, and the user will be able to select that application and open it. Now, if you're trying to get a specific application by default, you will have this exception, name not found, even though that application is installed. We consider nowadays that users don't want to share all the installed application to all the other applications by default. So if you're just trying to check if an application is installed without declaring it in your manifest, I'm going to show you after that how to do it, you will just have a name not found exception. If you want to know if a specific application or list of specific applications are installed, you need to add that queries tag in your manifest file. And there you will put the Android package names of those applications, com.examples.store, for example, or the ones you are looking for. And you can put multiple packages there. But if you want to just check all the application handling, sending, for example, images, rather than having to list them all, and to be honest, there may be thousands, if it's not hundreds of thousands applications that can handle this intent on the Google Play Store, rather than trying to check them all and add them in your manifest file, you can add instead this intent filter, which is the name of the intent with a MIME type filter in this case. So in this case, let me, it tells the package managers, I want to be able to check all the installed apps that can handle sending JPG images. And you can check, obviously, image./star if you want to get all the application that can handle all the type of images. So with these properties in your manifest, you will be able to get the get install packages in your results. It doesn't bring up a new permission. It's more for accountability and more transparency. In practice, we found that with both these two ways, you can handle most of the use cases that are required to be played on Android platform. But there are some specific use cases where you actually need to query all packages, probably, for example, like an antivirus. For those cases, we still provide a another way around, and in this case, it's a permission which is query all packages. But so you know, this permission is protected by some Google Play policy, which means your application needs to be reviewed before getting access to that permission. So it's not an automatic grant. You have to go through a specific review. So that's why I'm saying for most cases, you don't need it, and a review doesn't mean automatically a grant. So make sure you just use one of the use cases I mentioned. But for some others, the main thing of trying to access all the packages installed is to provide a more native experience. And for that, we actually updated and added some flags around the Instant Launcher. So by default, whenever you put Action View and put Google News, for example, website, you will have this list where you have Google Chrome as well as Google News. But if you want to have like a more native experience, you probably may not want to have the browsers being listed there, only the native application, the ones which are not browsers. And for that, we added a new flag. Flag activity require non-browser. And when you add that, if you have no application that can handle it natively, so meaning not being a browser, you will have this activity not found exception, which you can code, and after that, launch this website, in this case, Google News, as part of a custom Chrome tab within your own application, for example. It's mostly, rather than having access and look which application are installed, you're more having a different view where you're just handling if no native application being installed. Obviously, all the browsers are native applications, but here it's not their main target, that kind of generic application. You will be able to catch that exception and show the user experience you want to provide in case no native application, as I say, can handle it. So again, here in this case, using this flag doesn't require any permission, and it doesn't require any manifest change. So I highly recommend you to use it. And for you to be able to test that, we added some updates on ADB, and you can enable or disable the package visibility feature on Android 11 for you to check if checking a package is blocked or if you have any issue with that. Now onto scope storage. So I know I only have 5 minutes left, so I'm gonna rush a bit, but still it's gonna be really interesting. So on Android 10, we introduced scope storage, which was our big change for us on how we think about storage. Before, storage was kind of an open access. You just need a permission and you have access to all of that. But that brought a lot of issues. Some of them is, first, you as a user may not want to grant access to all your storage. You may just want actually only media files and the rest being separated. And the second thing is, for phones that don't have that much of space, whenever they look at the space used by an application, most of the time that storage use is only reflecting the cache as well as the internal storage, but not any files created through Media Store. And now with Android 10 enabling scope storage and obviously Android 11, you have some collection where you can create some photos, some videos, or some music without even asking the permission. You need to use the read external storage permission or write external storage permission only if you're trying to edit a media file created by another application. So your own files, the one you created, doesn't mean that they have to stay on your internal storage. You can modify them without problem. But the one created by other application, you will have to ask that permission first. Also, we're removing by default, if you don't have any location permission granted, any of EXIF metadata around where this photo has been taken. We're removing them on the fly like that. By default, application can't have access to those metadata that can be private and the user may not want to grant. And for all the other non-media files, you can use the system picker, which is the storage access framework APIs, to be able to access any of those. So as I mentioned, we brought some changes on Android 10. I'm just going a bit more quickly because I don't have that much of time and I don't want to overtake on Chet's talk. But we received a lot of feedback there. and we brought much better integration with the system on Android 11 with sub-storage. First one is storage being renamed to files and media, so it's more clear to the user which part of their private data you're accessing. And with Target SDK version R, write external storage and write media storage do not grant any additional write access. So rather than asking for 2 permission, you can just stick to read external storage. Obviously, you need to be more careful for previous versions, so you can just put a max SDK version as a property in your manifest permissions. But further on, from R, you don't need to ask for write external storage. And you can modify in bulk both modifying and deleting media files with Android R. So the great thing there is you don't have to ask for each files, which was the case on Android 10. You can just ask them in bulk. You can designate some media as favorite. So in the system gallery, there would be a favorite collection. So it's kind of a virtual album. And whenever your application is setting some specific file as favorite, they will appear in that collection. You can also put some media in the trash collection, which means those files will stay in a trash collection for 30 days and after that being removed. So rather than being removed and the user regretting doing that, they will still be able to go to that trash and restore them. So to be able to do this bulk write or delete request, we're introducing this mediastore.createWriteRequest method that allows you to send the list of content URIs that you want to delete or modify in bulk. And that UI will, the dialog will be presented to the user, and they can select or not to grant you that access. So we're adding some file access restriction because we think those folders are kind of important and should not be given just easily like that. So Action Open Document Tree doesn't allow to access to the root of the storage, nor the downloads or Android data or Android OBB folders. It doesn't mean you can't have access to those files. You can still request a specific file or specific subfolder in those, but you won't be able to access to the whole folder or to the root of storage. And for Action Open Document, you won't be able to access data or OBB as we consider those folders being private to their applications and should not be able to be open in the wild. The other feedback we got, and we made big improvement for developer, is we have a direct file path access for media, which means if you can't use Media Store for any reason, you're not being used to Content Resolver, even though we highly improved there, we uploaded a lot of sample, a lot of documentation to guide you. But if you're using an external library like FFmpeg, for example, that needs to have access to a direct file path, we brought that back in Android 11. Underneath is still using Media Store. It's just transparent for you as a user, as a developer, sorry. We're using Fuse, which is a virtual file system on Unix system. And as Android is using this base, we're having this kind of virtual file system requesting Media Store to give you access. So it's not a better way, it's not a native way to access files, it's going through Media Store. So if you're really focused on performance and need to make sure you have the best performance for your apps, Media Store is still the best API for that. Direct file path access is for those that can't use Media Store because of what I mentioned earlier. So I highly recommend you to use Media Store rather than to use the direct file path access if you don't need to. So open and first read are fairly expensive with direct path access, and overall you should always monitor with this API how it's impacting your application. So I know I'm just a bit overboard now in terms of time, so I'm just going through quickly the last part. For applications that are more considered productivity application like file manager, backup and restores, antivirus, or maybe a word processor application that use heavily the storage access framework, and need to be able to show a proper view inside of it. We brought the all file access permission, which is a permission that gives you access to all the external storage, but is granted through a Google Play policy. So it's not everyone that can access for it. You need to explain when you're submitting your application that you have a proper use case for it. And another restriction we brought, again, to protect further developers as well as users, is external storage folders of applications are not visible anymore if you target Android R. If you put it in a shared directory, like the Photos directory, the video directory, the download directory, it's okay. But if you put it in your own external directory from your app, other application won't be able to access it. So it will protect you further, but you should make sure that your application is not assuming having that access on Android 11. So some quick other important changes, and after that, I will hand over to Chet. First thing, we saw that read font state has been used a lot to provide a really good experience for users, making sure that we're pausing a game or something else if a ringing is happening, or if the phone is in idle state in terms of getting a call or not. But read font state permission allow having access to the phone numbers, so the one actually attached to the SIM card on the device. And that's not something pleasant that Android users want to have. So what we did is we separated this access into two permissions. The first one, read phone state, will just get you the phone state. Are you having a call or not? And the second one, phone numbers, read phone numbers, will actually get you the SIM card phone number, and you should not use it if you don't have a proper use case. It's protected by target API level R, but you should get ready to update it and make sure to access only what you need in your application rather than having a broad access. So you can obviously use Mac's SDK version to make sure you have a compatibility on previous devices. We brought also some MAC address restrictions. I'm not going too much in details. It's really for the people who have been trying to access those private information. We have some online documentation. Make sure to have a look if you were having access to those before. And lastly, if you were trying to draw on top of other apps, the action manage overlay permission intent is no longer supports a package name being supplied in the data URI. The users needs to grant that directly through the settings rather than having access to it directly through the intent. So that's for me on privacy. Sorry for taking a bit more time. I will be here to answer all your questions afterwards. And now I will hand over to my colleague Chet.
Thanks, Yacine. Let me see if I can present the right tab here. All right. Hopefully you're seeing what I want you to see, and you're not seeing my private inbox instead. All right. I'm going to talk about modern Android development. But first, thanks for hosting this thing. Thanks for everybody tuning in, and thanks for all the organizers working hard together to be a part of this summer event series that we had. It was very unfortunate, especially if you work in developer relations, for all of the in-person events to suddenly overnight go away and have no ability to actually meet up with developers, either at the large company events like Google I/O or at meetups and conferences throughout the world. But it was kind of amazing to see how quickly the community flipped and was able to create these online events with our help in some cases. But honestly, we didn't do much here. We just said, hey, why don't we have a series here, and we'll provide some content and speakers when we can. But really, the organizational stuff and the infrastructure to handle these things was on the community. So thanks for doing that and allowing us the ability to actually talk with people, even though we can't leave our office, basically. So nice to be here in Nairobi and all of the other places that are tuning into this thing at the same time. Let's talk about modern Android development. This is a phrase that we have used a few times, and we mean something in particular by it, but it's a little hard maybe to understand what it is we mean when we talk about modern Android development. So the point of this talk is to really sort of clarify what we mean and what you should think about when you hear the phrase modern Android development. And more importantly, it's not about the phrase, it's about the technologies that you should incorporate into your Android development experience to create better, more robust, and more scalable applications across versions and devices throughout the massive ecosystem that Android has. So I should point out too that this is not a new phrase. We've actually been using this phrase for a while and kind of meant slightly different things by it. So we've sort of converged on a common meaning. But the first time I'm aware of was a presentation that I gave with Romain 2 years ago in Paris at Android Makers, where we talked about modern Android development. And then shortly after that, also at Devox in Paris, we talked about modern Android development. Then at Google I/O a few weeks after that, we talked about modern Android development. And then at the Android Developers Summit in 2019, again, we talked about modern Android development. And it has also been mentioned in keynotes before. And as I said, we sort of meant slightly different things when we use this phrase. But now we've converged on what I would say is sort of a definition of what it is. And it's an evolving definition as well. As we add new capabilities to the libraries and the technologies that I'll talk about, those will be incorporated into modern Android development. I think of it as being the optional set of things that you can choose to use and you really should choose to use to have a better development experience. So first of all, let's talk about what I'll call classic Android development. So there were a lot of things about developing for Android from the early days that have always been there and for the most part are still there, right? Because things, especially in an API surface, don't go away. Instead, they stick around. Maybe it's not the best way to do things, but it's not like we can remove those things because then we would break apps. Right. So initially, the first SDK release came out, lovingly called M3. It stood for Milestone 3 because the internal team had milestones 1 and 2 before that, and 3 seemed to be the next number. So M3 came out, first SDK that launched. This was the first capability that external people had for actually developing Android apps. And then things churned along the way toward 1.0 and APIs changed, but this had a lot of the fundamentals that are even still there. There was the use of the Java programming language. There were the platform APIs that we offered, many of which are still there in a very similar state as they were in this early release. We used Eclipse as the IDE, the development tool that everybody used. We had the ADT Android development tool plugin for Eclipse that you would use for actually writing the code and debugging. And we had APKs as the delivery mechanism, right? You basically zip up your application, all the resources, upload it to the Play Store, and away you go. Then 1.0 came out about a year later. So migrated some of those APIs into their final form, but essentially shipped all of that stuff in that final form so the developers could really count on that, and then actually upload your applications to the Play Store and get busy with that developer life on the Android platform. Over the years, we introduced many, many more platform APIs and fixes and functionality. And then in 2013, we introduced Android Studio based on IntelliJ as the new IDE that developers should use. In 2017, 3 years ago, we introduced Kotlin support in Android Studio. Developers were using Kotlin already, but this is the part where we actually started supporting it. More importantly, where we started not breaking developers with new releases of the tool. Architecture components was the first significant piece of what we would later call Jetpack, or also confusingly Android X, where we took a look at some of the pain points of Android development and tried to solve those in very significant ways with things like life cycles and view models. App Bundles was introduced last year as a new distribution mechanism by the Play Store. And I'm going to take a look at some of these things, some of these elements of classic Android development, sort of look at where they were and where they are now in the context of modern Android development. So First of all, the language that we chose was the Java programming language. Great choice, huge developer base. Like people, whenever you come to a new platform, there's so much that you need to learn about, programming a mobile application, the APIs that we have, the capabilities that we have, building for a constrained device, all these things that developers needed to spin up on. It's kind of nice if you can eliminate some of those variables and allow people to build on experience that they already have. And so the fact that so many people wrote Java Java programming language applications already meant that they could build on that experience and then introduce the new Android concepts to it. So that was great. There were tools out there, a lot of tools out there, and a lot of them were free, including Eclipse. So people could use these existing tools. We didn't need to depend on people purchasing tools in order to become developers for the platform. There were existing libraries and middleware out there that people used. And practices that they used in developing their applications, patterns for writing their applications that they could then depend on. Again, it's about eliminating the variables and allowing developers to sort of build on what they already had and then introduce the new concepts as necessary. And also, honestly, for Java programming language, as well as some other more modern languages, the ability to not have to worry about memory allocation was kind of a big deal, right? Making sure that you're not leaking memory on the device because you forgot to free that thing, or calling into a null reference because you did free it and then you forgot about it in this complex code base that you have. Let's see. Sorry, too many things happening on my computer. All right, so that was the language. Now let's talk about the tools. So previously we had Eclipse and the Android development tool, the plugin that we used. Great thing, it was free, right? So again, we didn't want developers from the beginning to have to pay for a source repository system to get access to the code. We didn't want to have them pay for a tool to write this thing. We wanted the barrier to entry for writing Android applications to be as low as possible. And so free was a really big selling point. Also, a lot of developers already used Eclipse for whatever their language development and platform development experience was, whether they're writing native code in Eclipse, or also it was a very popular tool for writing Java programming language code at the time. So that was great. They could depend on that experience with the tool. Also, I should point out that it was free. That was kind of nice. There was the ability to integrate in subtools in the IDE. So when we introduced a new tool, we could write it with the IDE, with the Eclipse platform, and then sort of integrate it next to these other tools that we had. That was useful, so you didn't just have standalone tools everywhere, although we kind of did anyway, but to some extent we could integrate those into a single IDE experience. And also, it was free. That was nice. All right, on the API front, so we talked about language, we talked about tools. APIs, one of the biggest parts of the development experience of Android, but really of any complex platform. So all of our APIs were in the platform. We released platform releases very frequently. I'll show a diagram of that, just show you how exactly frequently we did that. There was new functionality in every release. There was also lots and lots of bug fixes as we basically played catch up, right? We were running really, really fast as a team to get all the functionality that developers and users wanted on their devices, and then fixing the problems that came about, and then spin another cycle, release another thing. So all of that worked out really well. We're running really fast. And so there's 1.0, and then, so watch this frequency, right? 1.0, 1.5, 1.6, 2.0. All of these are coming within months, sometimes even weeks of each other. In general, these earlier releases were often developed in parallel. So there were 2, sometimes maybe even 3 releases happening at the same time on the team, just because of the things that we needed to do to play catch up. So we did that for a while, and then finally it slowed down to an annual cadence, and everybody breathed a sigh of relief internally because we weren't rushing quite so hard on quite as many things in parallel, but externally as well, because then developers didn't need to absorb all this information on such a frequent basis. Partners didn't need to integrate all of these releases and do all their quality testing every time we spun the platform. And so an annual cadence is something that's a little bit easier for people to deal with. on a regular basis. And then Android 10 came out and life is good. All right. And then finally, the fourth thing I want to talk about is distribution. So in the early days, it was APKs. It was basically a zip file, right? You zip up all your code and your resources and you are done. You install it on the device, you put it up to the Play Store downloads that APK. But what if there are several configurations that you want to handle? What if you want to support different languages or different screens, different form factors for the devices? Then there are two approaches. You could have more APKs. You could have an APK per specific configuration, or you could just have one monolithic APK that has everything that it needs into it. All right, so that is the state of classic Android. And here are some of the problems. I alluded to some of these as we went along. So Java programming language, solid language, no problems with it, but it is verbose, right? There are more modern languages and approaches and patterns that people have come up with in the years since it was first introduced that make it easier to write code that does the right thing without quite as much boilerplate as that language requires. On the tools front, Eclipse and ADT was great because, you know, it was free and it had good capabilities that we needed. It was very difficult to customize, right? It was difficult for us to change some of the internal. We really needed to sort of work around the infrastructure that Eclipse had, and there wasn't really much that we could do about that. The subtools that we integrated, they tended to have inconsistent UIs. Like there just wasn't quite the level of customization flexibility that we needed in there. And at a certain point, the core IDE was not being as actively maintained. In the early days, there were large companies that were sort of pushing core development and a lot of external open source contributions as well. And then it got to a certain state of popularity, and that was about it, right? It didn't really evolve after that. And we didn't notice, so we couldn't evolve it, but others weren't pushing it either. And so there were a lot of things that we kept having to work around that we really couldn't fix at a fundamental level, and we had no control over this thing. It was not our tool. It was an open source tool sponsored by other companies, and there really wasn't anything that we could do to change the fundamentals. On the API front, so we did all the stuff, as I said, in the platform, and this meant that all of the developers were limited by what their users could get, right? So if the users were running an earlier release, developers may be excited about a new bug fix or a new piece of functionality, but that may not matter because maybe their users weren't going to get that release anytime soon. So they really needed to handle the lowest common denominator of what their user base had instead. So it was difficult for developers to adopt these new exciting technologies. And then it was difficult for us on the platform team to actually push these new technologies and say, no, really, everybody needs this thing. It's awesome. And then the answer would be, I will care in 3 years when my users have that release. Until then, I have other things to do. And bug fixes too, really important bug fixes to go out, but if the user is running an old release, they can't get it. Now we've gotten better with that with security releases, at least over the years, but if you have a bug fix to some complicated system in there, you're not going to just be able to auto push that thing. Security releases are really focused on fixing security issues, not every bug fix across the platform, because you don't want to introduce new bugs along the way. Also, a lot of the early APIs were complicated, and there were a few reasons for this. One being the team was running really fast, and there wasn't, designed by committee for decades coming out with the perfect API because they did not have the time, right? The important thing was to ship the platform in time for it to become actually relevant and usable. But also there were constraints for early devices. We still have constrained devices and battery savings and things we need to keep in mind for the mobile space, but there is so much more memory, so much more fast CPUs and GPUs to rely on that the constraints that we have now are much different and much more flexible than the constraints that we had then. And so we built in a lot of the constraints into the APIs and created a somewhat complicated environment in some of the API space. And there were just some traditional things developers always bang their head against, like the life cycle of Android, how to deal with storage considerations, especially with some of the new privacy stuff coming up, navigating in your app, the confusion between back and up. So these common problems that people kept hitting that were inherently tied to the APIs that we had in the platform for years. And then finally, the fourth area, distribution. So APKs are great. It's pretty simple. You zip that thing up and you upload it. But if you do have lots of configurations, users across countries, different kinds of form factors on these devices, then developers end up having these massive APKs that handle all of these situations. And then the download for everybody is much larger than it needs to be. Or you can have many APKs for all of these different situations, and then the onus is upon you to manage that, right? Where do you actually put these things? How do you make sure that you're building the right builds for all these people? How do you make sure that they're uploaded correctly, downloaded correctly? Like, it just becomes sort of an organizational nightmare. So there was something that we needed to do there as well. So that brings up the solution that we've come up with, which is, again, what we call modern Android development. I will read this lovely quote here: development tools, APIs, language, and distribution technologies recommended by the Android team to help developers be productive and to create better apps that run across billions of devices. So I should point out, too, there's a little subset here that's not spelled out, where everything I'm talking about today, these are optional pieces, right? Platform APIs, not optional. You're going to use those anyway. And some of the constraints that we're dealing with, not optional. But the pieces I want to talk about today for modern Android development, they are optional, but we want people to use them because we do think that it makes your development life better and easier. So here's the way it looks in a silly diagram that I made. We think of these as the pillars of modern Android development, which hold that lovely triangle roof. You can guarantee whenever I make a drawing, the geometry is going to be very, very simple, because that's about all I can manage. So we have language, we have tools, we have APIs, and we have distribution. And then at the bottom layer of that, this is not part of modern Android development. I just want to point out, we still have the foundation, right? We still have the Play Store that you're dealing with, and all the capabilities like the console that has. And we have all the APIs in the platform. Those do not go away, but where possible, choose some of the optional pieces that I'm about to go through. Starting with language, let us talk about Kotlin. So Kotlin's timeline looks something like this. The language went 1.0 way back in 2016. And then in 2017, we announced that we officially supported it. What that meant was we would officially stop breaking everyone. A lot of our developers were already using Kotlin at that time, which was fantastic. But then we would release a new version of the tool and something would change in the Gradle plugin or whatever, and we would break them. And then there'd be a series of bug fixes. Maybe JetBrains would react, maybe what we would react, we would eventually fix it, but that was sort of tortuous. So we needed to fix that. So we officially supported it. We also started using it internally. A lot of the tools work actually moved to use Kotlin instead because it is so good. And then at Google I/O last year, we said that we're going Kotlin first, which meant a lot of effort toward docs and training and samples, helping everybody spin up on using this thing. And also a lot of our development, especially in the unbundled libraries, can now move to Kotlin. We can't do that in the platform. That is still based around Java programming language APIs. But some of the libraries that I'll talk about are coming out either with APIs that are intended for use by Kotlin developers, or they're even being written completely in Kotlin to take advantage of some of the capabilities that language has. And then the most recent development is that coroutines went stable a while ago. Flow came out recently, and we are now saying for asynchronous programming, which is a lot of what we do, especially in the UI space, coroutines is the preferred approach. There are different approaches out there that you can use. I'm not telling you not to. We are saying that this is a better way to get that job done, and it's a really good reason to use Kotlin to begin with. And this is where we're at right now. So here are some of the reasons that we chose Kotlin. It's an expressive language, by which I mean a lot less boilerplate than all of the Java programming language patterns that we are used to. Passing the lambdas around, properties, getters and setters, like every data classes in Kotlin, all of these things that are just sort of built into either the language and the keywords of the language itself, or some of the extension functions and extension function capabilities of Kotlin mean that you can write a lot less code to do a lot more stuff. Safety is all about nullability, building into the language the concept of things being nullable or non-nullable, and then the compiler being able to check that contract, right? So if you are calling some code that says, I can't accept a null parameter, this is non-nullable, and you're calling it with a variable that can be null, then that's going to get flagged at build time, which might be a pain to deal with, but it is way better than dealing with it at runtime. If you call it with something that actually is null and it wasn't expected, then you're going to crash on the user's device. You really want to fix that bug before your application goes out. Interoperability was really key for us. When we talked to developers about introducing a new language, the idea, do you want a new language? Like over the years, we talked to developers occasionally and say, is this one of the priorities for you? And everyone said, no, we have a language that works. There are a lot of really complicated things going on. Why don't we, fix the actual problems that we have instead of, introducing some new learning curve? Oh, unless it's Kotlin. And the reason is because of interoperability, because we don't want to take on the job, nor like either for us or for learning for you, of introducing, a whole new set of APIs based on some other language and construct. But the fact that we can actually use our existing APIs built in and exposed to the Java programming language, even if you're doing Kotlin development, means there's no work to be done there and there's nothing new to be learned there, right? Same APIs, but the ability to actually call it from either code is fantastic. Similarly, in your application code, you can migrate to Kotlin piece by piece, right? You don't have to completely rewrite your application. Instead, maybe you have a new activity, a new fragment, you could write that in Kotlin and then slowly migrate your code over to this better development experience. In the meantime, you're interoperating between the two different code bases, two different languages very easily. And then finally, structured concurrency. I alluded to this earlier. The ability to actually write this asynchronous code using coroutines and flow means that you can get much easier to read, more maintainable and more obvious code for doing this fairly complex and fairly common task. So if we look at this in code, we can see some of these in examples. Nullability in the type system, the ability to actually declare parameters or variables and say this is null, this is nullable or this is non-nullable, and then the compiler has enough information to go ahead and check the references to that variable to see whether they actually obey that contract. Lambdas, very important, passing lambdas around all over the place in a very terse and a very readable way. In the ability to like pull the lambda outside of the parameters of the function. So it makes it this sort of really nice readable code where you can see what's going on there. Extension functions, probably my favorite feature in the language, the ability to essentially stuff in capability to an existing class. One of the pains in developing APIs is everything has to be backward compatible. You can't just, rewrite the string class because you wanted a new method, but then you can, add it in there, but then only people on the new release can use that new method. With extension functions, you can add in new methods, people pull in your library, and then they can use that method as if, or that function in Kotlin, as if it existed in the original class. So you can have a new capitalized function in string, and you can then call that as if it's actually on the string class. So in your application code, it reads correctly. Like that is where that functionality should live, even though it may not be part of the official API. And so it just makes the code a lot more readable and a lot more maintainable in your application code. Template expressions, the ability to actually have an expression inside of a string, so that you don't have to go through that arduous process of formatting things and not getting compiler checks on what you're doing using the typical approach that you would do if you were not in Kotlin. And then properties, that funny dance that we've always played with fields versus getters and setters, and obeying the Java Bean spec, and make these private but make those public over there, but then they need to, it's all, it requires so much code, and it also requires a consistent approach, and it's so easy for someone to surface a field by mistake. Well, no one will ever want anything else besides the value from this thing, and so they surface the field, and now it's part of the public API, and then sometime later they decide, I really would like to log accesses to this field, and it's too late. Right, because public API is the public API. So Kotlin has the ability, has the capability built into the language to have properties automatically exposed as getters and setters. There is no confusion there. There are only properties. All right, so some of the other reasons we chose Kotlin include speed, by which I mean the speed of development, because it is so much faster to actually write this code. None of that boilerplate stuff, a lot more intuitive. But also the speed of the development of the language itself, the ability for that team to come up with this really nice mechanism for coroutines and then introduce flow for for these streams of data using coroutines. The language is evolving steadily. Also, the ability to have extension functions so that they don't need a new keyword every time they come up with a new way of doing things. They can use the ability of the language itself to sort of build in other capabilities that just look like they're part of this cohesive whole for the language. There's been great uptake so far. There's been 60% of pro Android developers using Kotlin. 70% of the top 1,000 apps on the Play Store contain Kotlin code to some degree. There are a lot of things that we're doing to continually improve Kotlin. One of those is in tooling. So we have lint checks being added all the time. We have a dedicated compiler team working with the JetBrains compiler team on things like making R8 faster, the optimizing compiler, as well as speeding up annotation processing, which turns out to be one of the more expensive things that happens in Kotlin compilation. There are various initiatives we've been working on. One of those is annotating the platform API. So as I said, we're leaving the platform APIs in the Java programming language because if it ain't broke, don't fix it. Like, don't spend all that time to rewrite that stuff. That doesn't make sense. We have this nice interop story. But we can take advantage of Kotlin capabilities for type safety to annotate those APIs so that if you are a Kotlin developer, you can actually call into platform APIs and get that same build time safety as you would if those were Kotlin APIs with nullable and non-null types. So we've added 4 annotations in recent releases. There's recently nullable and recently non-null. The recently version means we've just added this annotation and this variable can be null or cannot be null. And if if the compiler detects that you are calling that incorrectly, it will trigger a warning in your build. You do not have to fix it, but it would really be happier if you did fix it. But maybe they were recently in the last release, and then we've upgraded them in this release to nullable and non-null annotations. And that actually does trigger a build failure, because wouldn't you rather catch it at build time than runtime anyway? So please fix your code and take advantage of these annotations that we've been adding. Other initiatives include the Kotlin extension libraries, building on that great capability for extension functions to actually add in some, you can think of them as syntactic sugar in a lot of cases, easier ways of doing things. So improving platform APIs, but outside the platform in a way that doesn't cause compatibility problems, but also in a way where you can now use these new APIs across various releases. So it's not hinged on the latest platform release. Instead, you can get KTX and build it on earlier versions instead. So let me show a small example of that. So we've always had this API in bitmap. To create a bitmap, so let's say we want to take a drawable and we want to draw it into a bitmap. So there are a few steps. So first we create a bitmap. We obviously need a width and height, and we also need to pass in this configuration, usually ARGB 8888. And then we have this drawable API. So you're going to need to create a canvas for the drawable or for the bitmap, and then you're going to draw with that canvas from the drawable. And then the resulting code looks something like this. You store your old bounds, you set the new bounds according to the configuration, the dimensions that you have. You create the bitmap with those parameters that were required. You create the canvas, you draw with that canvas, and then you restore the bounds. Not a lot of code, but there's just this boilerplate you go through every single time. In KTX, we introduced this new function called toBitmap, and it does everything for you. If you look at the implementation of toBitmap, it essentially is the code that I show down below, but it takes only parameters that it needs in order to do that for you. One of the things I want to point out here is one of my other favorite features in Kotlin is default parameter values. So that config is a nullable type, which has a default value of null. And if it receives a value of null, it will pick the obvious, it will pick ARGB 8888, because that's usually what you want anyway, which means you don't have to supply that parameter. Instead, we will assume what you want. And again, your code becomes more concise and terse. And then all you have to do to draw the drawable to the bitmap is this. There are developments we've been doing in APIs, some of the libraries I'll talk about for APIs, like Room and Work Manager, that have introduced Kotlin-specific capabilities, like using coroutines, because They're just better for doing asynchronous behavior, which a lot of these APIs are really built around. The Paging 3 library was recently rewritten completely in Kotlin to make that also all of its asynchronous behavior, paging the data in from the database, much better and easier to use. And Jetpack Compose is being written, the future UI toolkit for Android is being written completely in Kotlin, taking advantage of all of the language capabilities to make that better. Lots of docs and training and samples and articles and videos. A bunch of those just came out this summer as part of the 11 Weeks in Android campaign that we've had. So lots of stuff going on in Kotlin. If you haven't checked it out yet, now is a perfect time to do so. I encourage you to do that. On the tools side, the second pillar, Android Studio. Please be using Android Studio. And I should point out too, the tool is not so much in the specific tools in and of themselves, but rather the way that they integrate with our APIs. Navigation is a perfect example of that. So is constraint layout and motion layout, where we have an API, we have a library that you can use, and we have a tool, a visual tool that allows you to integrate with that library and visualize these changes that you're making in your application. So history of Android Studio, we announced it in 2013. And then a few years later, we deprecated Eclipse. So we did maintain it for a while, but frankly, Android Studio was mature and robust and a much better solution. So Eclipse and the ADT plugin went away. We also introduced Constraint Layout Editor at that time. Constraint Layout is a really powerful layout system, but having a visual editor makes it a lot easier to use. Kotlin supports, I mentioned this one before, we also introduced the new suite of profilers with the initial profilers of CPU, memory, as well as network capabilities. We introduced the new DEX compiler in 3.1 and 3.2. We introduced more profilers into the suite, so you can now track battery usage, as well as the overall system performance using systrace. Navigation editor came out last year, very powerful way of defining and creating and editing the navigation flows in your application in a visual way, which is pretty cool. View binding, because everybody has always loved find view by ID, right? So this allows you to have a fast and easy and type-safe way to access essentially the fields of your UI without having to go extract those using find view by ID. And then motion editor. This is the visual tool for motion layout. Motion layout is a really powerful way for creating rich animations, but it's a lot easier with a visual tool, especially for something as visually complicated as animations. So meanwhile, the fundamental tool has really powerful refactoring capabilities. They're like Eclipse, so we could build in subtools into Eclipse, but we were really kind of hamstrung by the flexibility of that underlying framework. But IntelliJ is a much more flexible framework to begin with, and we can extend the tool in many powerful ways. And so all of the new tool work that we're going is integrating into this one lovely IDE experience where all the tools actually look like they belong together. And I can't say the same for the tools on the early platform. We are working closely with JetBrains on a lot of this stuff. We work on the Android Studio plugin and all of those subtools that go in there, but we also collaborate with them on the compiler. Very tight integration with Kotlin, the new language, all the new capabilities, lint checks, compilation, all that stuff that's going on there, as well as enhanced capabilities for Gradle all the time. As I said before, the tool is not so much about what you're running in Android Studio in and of itself, but also the integration with all the APIs and the libraries that we offer as well. And we'll see examples of that. All right, Android Jetpack. Let's talk about the API. So this is essentially a subset of Android Jetpack. If you look at Jetpack, it's a suite of many, many, many libraries. I think there are like over 80 Android X libraries now. Android X is the namespace. Jetpack is sort of the marketing name that we refer to this for. It's these unbundled libraries that you can use across releases for doing everything from, I don't know, I think there's some, there's biometrics capabilities, there's the architecture component stuff that I mentioned, there's Compat, there's Core UI, Jetpack Compose is part of this, a really wide variety. So when we think of modern Android development, it is a subset of that in specific areas that I'll get into. So the modern Android development APIs essentially started, I think of this as starting with constraint layout when that first came out, a new powerful way of doing more powerful and flexible layouts. And then the architecture component stuff, the 1.0 there with solving problems, really complicated API problems for developers like life cycles, view model, storage using Room. And then we announced Jetpack. So all of those things came out on their own. And then we basically folded them in together and said, okay, this is this Jetpack suite that we now offer. And then we added more capabilities, paging for paging data in from a database into recycler view, navigation for navigating between the screens of your application, work manager for handling deferrable jobs. Material design components came online, making it much easier to actually use our design system that we came up with by having concrete components that you could build into your application. And then we announced Jetpack Compose last year, as well as Camera X, which is now in beta. I'll talk about both of those. And then motion layouts and motion editor came out recently. I think 4.0 just came out with a motion editor. So finally, the visual tool is here. You could use the API before, but now you can use the visual tool for a much more powerful and easy way of getting rich animations and UIs. So constraint layouts, the ability to have this, you can think of it as relative layout done right. It's the ability to position elements of the UI relative to each other, but also relative to other things. Like you can have these key lines. So if your users are saying everything needs to be offset by an 8 DP grid, well, you can use, you can add guides to the UI and then offset really rich set of capabilities, especially with a visual tool that works really well. Motion layout, especially with the editor, this ability to essentially have, I think of it as transitions on stick and define the animation that goes between them. Transitions, part of the core platform APIs and also backported into Android X, allows you the before, after, and the animation, but there's not a lot of flexibility in how you run that animation. It's kind of a set and forget model. And it has some rather brittle edges in there as for customization. But motion layouts and the visual editor allow you to say, okay, well, that's the default animation, but what I want to do is move along a path like this, and I want to use timing like that, and really customize that experience, as well as to integrate it in with user interaction so the user can scroll and essentially scrub the animation at the same time, which is not possible with transitions. Transitions were all about just running an animation. But motion layout and the visual editor are a much richer experience. So life cycles, always a complicated thing. Memorize this diagram, that's all we asked. And also implement all of these overrides. So if you ever wanted to know what state, what lifecycle state your application was in, you had to override all of these things, right? You had to implement activity, override these things, and then track the state manually. And hopefully you would do the right thing, because otherwise you're leaking, you're crashing, all sorts of horrible things happen. So we looked at this in the early days of architecture components as a chance to make things much easier for developers. So now you can actually set an observer instead, and then you can get a callback from that observer and then just query, what state am I in this life cycle, and then do the right thing. We also came up with a better way of doing architecture. We offer an opinion. If you have your own way of doing architecture, that's great. We're not trying to tell you to do this, but we allowed through some of the new architecture component stuff, a much easier way to do this, where now we have the UI in one part of your application, we have the state in the other, and those should be separate, right? Don't nest those things together. Now the UI can observe on the things that are going on with the data and the state of the application, and then the data can be passed back in these on-change methods back into the UI, and then the UI can react to those. The data side then probably builds on some sort of database like SQLite or a Room. The Room DAO is pretty easy to create. One thing I should note is it has suspend function, so it's really easy to integrate with coroutines and with asynchronous programming behavior. And you're going to need asynchronous programming behavior for database queries, because you don't want to do this stuff on the main thread. And you can use these annotations to get automatic implementations for the DAO, or you can set up these custom queries like we have here in this code for get all. So then we have the Room DAO on the bottom of that. And you can also integrate with paging so that instead of returning back data, you can return back a paged list of data instead. All of these APIs were built to work together. So view model and live data, they're all lifecycle aware, and makes it much easier to avoid leaks and problems in your application. Room uses the concept of view model and live data objects for exposing these objects that you can then observe changes on. And Room now uses coroutines and flow, as I mentioned before, for doing all that hard asynchronous programming. I should also point out that the architecture components are RxJava friendly. We're not trying to take the place of RxJava. We understand a lot of application developers use RxJava, and it's very powerful. It's also very large, right? So if you need a solution for this stuff, we wanted to offer a very focused solution. But if you prefer continuing to use your RxJava stuff, that's fine. We have APIs and patterns that work just fine for that. Navigation component is a new thing that came out in the last couple of years. And it now integrates into some of the templates that you have in Android Studio. So you can create a basic activity, and then it gives you these two fragments that are destinations you can automatically navigate between. You can also look at the XML. Since it's a tool, there's usually XML code underlying these things. You can see each of those destinations is a fragment in which are defined these actions, which are basically the edges along that graph. When I navigate from this destination to that other one, here's the action that defines that navigation. And then in your code, there's usually a UI element that would trigger that, and then you would call this action to navigate to the appropriate destination. Let's see. There's a lot of capabilities in navigation. I don't have time to go into all of this stuff. Safe args for passing arguments between these destinations. We make it much easier to implement the single activity model. Traditionally, Android developers had multiple activities, really powerful, but we'd like people to move away from that. It's a much richer experience to have a single window, a single UI surface where things happen, especially because then the Chrome is static. There are still things that are appropriate for multiple activities, like if you have a deep link in your application, but in general, single activity is good. Navigation makes that much easier with its integration with fragments. Up versus back has always been inconsistent between applications. It's kind of a hard UI problem. Navigation component simplifies that and makes it more consistent, handles all of that work for you. And there's also new support for on-demand dynamic features. So even if your application has not yet downloaded a dynamic feature, you can still navigate to that, and that will trigger the system to automatically download it and install to then navigate to that destination. I am running a little, I'm going to go really fast now because I'm running a little bit behind. So Work Manager is for running deferrable and guaranteed background work. It is compatible all the way back to API level 14. So it essentially takes the place of things that developers were doing on their own that were really tedious. You probably want to use the framework job dispatcher, job scheduler API, but maybe you're on a release that doesn't have that, or it doesn't have the right bug fixes for you on that release. And so then you see whether the Play Services version of that or the Firebase job dispatcher is available. And if that's not there, then maybe you have an alarm manager, some more manual process. Work Manager essentially does all of that and gives you a single API. So you ask it to do the thing, and then it figures out how best to do it on the runtime device. It handles periodic tasks. It handles being able to chain tasks to either run in parallel or after one another. And it also defines constraints. I only want to do this thing when I'm on battery or when I'm on unmetered network, whatever that is. So let's look at a really quick example. Let's say you want to run 3 separate filters on an image, and then you want to compress the result, and then you want to upload it. The filters can happen all at the same time. After all of that stuff is done, then we compress and then we upload. And there's some constraints along the way. I only want to run the filters when the battery is not low. And so you can plug in all of this information into Work Manager, and it will schedule the jobs to happen at the right time. So you implement a worker, you implement this do work function, and then you can define these optional constraints. I only want to do this when we're not in low battery mode. And then I'm going to create this this work here, build in the constraints there, and then schedule things to happen. So I'm going to schedule this with all the filters running in parallel, or maybe after those are done, then I enqueue the compression, then the upload, and then start the job. We also make it easier to handle foreground services. Note, don't do this too often because it is a battery problem. It's also a UI problem if all of these apps are populating the notification panel with foreground services all the time. But if you have to have work run, this is one of the ways to accomplish that. Camera X, really quickly, it's making camera development much easier, especially across the wide ecosystem that Android provides. So APIs that work all the way back to API 21 on the platform, and workarounds for different inconsistencies across the device ecosystem that are embedded in the library itself. So you call a single API and then it figures out what it needs to do on the runtime device. And easy to use APIs for doing specific use cases. The 3 use cases it handles right now are preview, so you can see the live camera, see what's going on, image analysis, so you can do things like ML, object detection, and then capture, actually snapping and saving that photograph. The capture example here, so we set the target resolution 600, 800. If you were using the direct Camera 2 APIs, if you asked for that resolution and that resolution was not available for some reason, you would need to handle that error and then figure out and iterate toward a resolution that the device was happy with. Camera X figures out the right thing for you to do. If it can't get that one, it will get as close as it can and just handle it without erroring out on you. Bind to lifecycle, so it's going to open and close the camera appropriately, so you're not stuck with this horrible resource leak, and then just easy APIs to, in this case, take the picture. All right, other advantages to the modern APIs, we release these things frequently. If you check the Android X release page every 2 weeks, there are a large handful of libraries coming out in alpha, beta, developer release, RC, or eventually stable. So constant bug fixes as well as functionality coming out across all of these different releases. Again, these are unbundled, right? This is not platform. So you should be able to take that library and run it across this current release as well as several releases before that. In many cases, way back to, it was API 14. I'm not sure if they've upgraded that since then. Camera X is specific to 21, but most of them run across many, many releases. Okay, final area, distribution. So I'm talking about Android app bundles. So first, let's take a look at the dynamic here. A large portion of the Android ecosystem has devices with very, very little memory, certainly very little free memory. And if they have very little free memory, chances are they are going to uninstall applications at an alarming rate, right? Which means maybe they downloaded and installed your app, but then they want to try something else and they're going to uninstall yours because they don't have the memory to have both on their system at the same time. Meanwhile, also, we track data that says the larger an application is, I mean, it makes sense, right? But here's the data. The larger an application is, the more likely it is to have an issue when downloading and installing, which means maybe the user didn't actually get the thing, even though they wanted it. And we've also tracked other data that says the smaller your download is, the smaller your APK is, the more people will install that thing. That is a motivator for people to not take up too much memory on their system. So we came up with this idea of app bundles, which is visualized here, which is instead of this monolithic APK where everything you shipped up as an APK downloads onto every device, instead you upload an app bundle and then the Play Store will automatically create an APK on the fly given the configuration of the device that wants that. It will create an APK just of the pieces that it needs, so it doesn't need all those different languages, doesn't need different screen format, whatever it is, and then it creates that temporary APK and downloads that to that device, offering massive size savings. So another way to visualize it is here, where each device gets a little bit different variation of the capabilities of the overall app bundle. And here in dynamic feature delivery, it also has the ability to deliver different dynamic features based on runtime device information. We've had over 500,000 of these apps in production right now, and that's going up all the time. 35% of the active installs right now are using app bundles, and nearly half of the top apps and games are using app bundles. Here's the important part that you want, though. This is the percentage average size savings that apps are seeing. So just by us doing the automatic creation of the APKs for you from the app bundle, you should be able to see an average of about 20% size savings. So I'm over time, but let me quickly summarize. That was modern Android development, and the 4 pillars that we talked about are language, by which we mean get on the Kotlin train now. Tools, you're obviously going to use Android Studio, but check out some of the new tools that we integrate, especially the ones that integrate with the new libraries that we're talking about, like navigation, motion editor, constraint layout editor. APIs, Jetpack is a huge surface area. Think about modern Android development as being specifically targeted around all the architecture and component stuff work going on, constraint layout and motion layouts, libraries that make richer UIs and richer UI experiences. Camera X in beta right now, hopefully in stable sometime soon, but much easier camera developments and material design components for just creating better UI experiences much more easily with those built-in components. And then finally, in distribution, get on the app bundle train and look into that for your application to allow us to give you size savings. There is a site with more information on d.android.com, modern-android-development. And that is it. Thank you. And I'm not sure what the next step is. I know that we got questions on a stream.
Yeah. Yes,
oh, hi.
We have. Yes, how are you? Yeah. So thank you so much for answering all of the questions. So let me just bring everyone so that I think everyone can see. Yes, good, perfect. So I'm just going to read the questions. So Fred is here, Yacine is here, Murat is here, and Chet is here. So quickly, first of all, is a big show of gratitude from us, I think, for you guys for taking time out even to answer it. And so the first question that has been asked here is, are there any other tips for reducing the sizes of the APKs? Yeah, I think I'm going to try and bunch them together. So I think on the APKs, it's, are there any other tips for reducing the sizes of the APKs? And yeah, that's the one on APKs for now.
Sure, I'll start since I was just talking about that. Definitely check out app bundles. That's an easy way to do it because you sort of get it automatically, especially if you have an application that works on multiple configurations with data that not all of your users need. But I should point out too, an easy way is look at, there's an APK analyzer in Studio that shows you things like, what are the sizes of different things in your application. Look at some of the larger ones and see whether it's actually the right thing that you want to be giving all of your users. For example, are you using really large images for everyone, or should you tune those for different screen formats? Are you, if you're bundling up large images with your applications, but you only use those as thumbnails, it seems like a really small thing, but it's not when you're talking about sizes of images or media files in general. I don't know if the others have anything to add.
Go ahead. Yacine, go ahead. I was going to suggest vector graphics. Yacine, your turn.
Something I definitely highlight to a lot of people is enable R8 as much as possible. I know some people may have had not a great experience because maybe you've been using a library that has a problem with R8, and unfortunately I see way too many times the default answer being, well, just disable R8, problem solved. R8 has a huge impact on first cleaning the code that you actually do not use within your app, because you may have a huge library and just use 5% of it. The second part, it will really first clear all the dead code you may have in your app, as well as shorten function name, property name. You would be surprised how R8 can have, how big the impact R8 can have on your build. So if you have a problem, make sure to try to figure out what's the problem. Most of the time, if it's not the only time, is mainly related to libraries or code using reflection. And for that, you should just highlight in your ProGuard file which part of your code you want to keep, rather than just disabling R8. So if you still have a problem with R8, please ping me. That interests me.
I'll share his Twitter handle just in case, so that guys can reach him also. So the other question that was asked is, I noticed companies like WhatsApp have a range of versions for various APIs. So does it mean that you have to do many app versions to support older to newer APIs. I don't know if I should take it again. So,
I understand the question. I can't speak for them. I don't know what they're doing. This relates to something I was talking about where if you want to optimize download size, you may end up creating, separate APKs for all the different situations. Why they're doing that across versions, I can't speak to. Like in general, you could have code in there that says, oh, if I'm on, the version that supports, let's say, job scheduler, then I'm going to use job schedule. Otherwise, I would do this other thing, but it's probably not worth, in general, creating a separate APK just for that separate code path. That seems like too much tedious organization. I don't know why offhand they would need to do that across versions unless there was like massive code paths to support these different things. Okay, so let's take an extreme example. What if your app was all images and you wanted to take advantage of, let's say, vector drawable before they were in the support library? Then maybe you want one version of your APK where everything could be simplified and downsized into something really, really optimized. But you knew that only people on that version going forward could use that APK. So maybe it's worth having a tiny APK for that one version, whereas for everybody else, they're going to need the larger one. It's just a very hypothetical for various reasons that I mentioned, but I don't know.
Okay, cool. So I think the person who's asked the question, if maybe your question has not been answered well, you could always do a follow-up and just tweet any one of them. I think Yacine has sacrificed. I guess they'll answer your question. The other question that's here, I think Murat, the one who talked about this. Are GWP ASAN reports on console as comprehensive as HW ASAN on runtime? I guess let me try and help also by posting the question on the chat section of our chat section. I think it will be way easier. So that's a question, and I think this is just comparing the reports that you have on console versus the reports that you have on runtime. And so he's wondering whether are they as comprehensive as the ones that you would have on runtime. The ones that you have on console, are they the same one?
I don't know offhand. I have not compared those reports. My understanding is the main difference between them is that HWASAN will run those reports. It'll trigger a crash and the report regardless of what address your memory misaccessed, right? Because it's basically layered on over the entire native heap and every memory access. And that's a lot of overhead. So what GWP ASAN does is a sampling approach where it's not the entire surface area. It's just a small portion of it to try to catch a small portion of the problems across the overall ecosystem. I would assume that it would use exactly the same mechanism and exactly the same reporting infrastructure internally to produce the information. It's really about only getting a subset of the memory accesses handled.
Okay, so another very interesting question is, everyone around the world is talking about 5G and everyone is interested and excited about 5G. But the problem that you have in the continent, and the person is asking, we are talking about 5G. So are the new APIs also going to help with low internet connectivity within the continent?
I don't have a direct answer here, but what I will say is 5G deployment is ongoing, so it's super early in most countries, if I don't say mistake. But the thing to know is, as a local developer in Kenya or Africa generally, is also targeting the wide world. So even though that 5G deployment may not come to Africa, to Africa is kind of global because it's really depending on the sub-regions of Africa. It may not come tomorrow to Kenya, but your customer may already be in South Korea where they're already enjoying 5G deployment there. So you should never think just too locally, because as a developer, you have the opportunity to target the whole world, and you should benefit that.
And even if you're thinking locally, your users might be traveling, and you can be in a metered network on roaming. You can be using the whole bandwidth of 5G, which you may not want to do. So you can still use the APIs.
And I guess part of the APIs has to do with reporting estimated upstream and downlink speed. So based on what your app thinks it's using based on these APIs, the idea is that as an application developer, you can adjust the user experience. So for example, if it's detected that the user's device is running on a slower network, you can optionally decide to serve up lower res graphics, hypothetically, and vice versa, right? If you're detected that your user is on a 5G caliber speed, you can correspondingly serve up higher res graphics to optimize the user experience. So I guess like even though we associate the term 5G with the APIs, the idea is to give developers more visibility into how your users or what network connectivities your users are on, so that you can adjust the user experience.
Okay, cool. Thank you. So the other question being asked is, are there any tips to improve Android Studio performance? I struggle to make it faster. I think let me combine this by putting it contextually, because I think most of the time I answer or deal with this one. It's like there's that bit of recommended RAM size, but then when I'm starting out in Android development, I don't have 8 GB, I don't have 16 GB. I'm starting out with 4 GB of RAM. Are there any other tips and tricks that probably you guys would have that would help people have Android Studio work faster?
So on that part, Murat, I will answer. But specifically here, I think there is just not one optimization. Otherwise, we'll have already enabled it for developers. But I will say, and I say that because I worked recently on Jetpack, so on the Android X source code, which is huge, is if you have a modular application, I highly recommend you to unload any module that you're not using. That has a huge impact in terms of RAM and CPU load. The second thing I will say is on some really limited RAM and CPU devices, I've seen that using an external device rather than the emulator being better. Obviously, the emulator, the improvement we did there are huge, and it's so much better than before. But on really hardly limited, I know like 2 GB or 3 GB, even 4 GB of RAM, not only for Android Studio, but globally for the computer, maybe a really restricted computer resources. I may recommend to use an external device. So that's just on the CPU and RAM performances. After that, on the part which may be a bit related is the build time taking more time, which maybe developers may be triggering a lot, and which affects how Android Studio may behave or not. I highly recommend you have a look at the build analyzer, which we introduced, if I don't say mistake, on Android 4.0. And it allows you to check all the steps happening within your Gradle build to figure out which part is taking more time. So maybe it may be an external plugin, a part of your code. It really helps you to figure out, because unfortunately, a lot of Android developers, including me when I started this job, so it's not something like super rare, we're not that comfortable with our build Gradle file. We just use the default one, and we keep adding code to it, but we don't really master it. And the build analyzer really, really helps on figuring out which parts really affect the building time, which per se affect also the Android Studio performances, because it may need to run much more code.
I'd also recommend writing less code.
Yeah. Okay, cool. Play Store. That's the other topic that I think is there are the two questions concerning the Play Store, or distribution for that matter. So the first question is on Play Store challenges. So we've had a bunch of Play Store accounts being shut down when they were still new. There's nothing that was published there. So why? I think the person asking why, and this is very frustrating for them in the continent. And so just maybe a comment on that, and like what is the criteria that's probably being used So that's a new Play Store account. Someone has a Play Store account. Nothing has been published, but then you find that he's been banned. The other question is on SMS apps. So considering that there are a bunch of legit apps using SMS reading permissions removed from the Play Store, are there granular permissions now or in the future that are going to prevent them from being unpublished from the Play Store?
I will answer the second question because I'm more comfortable with. I worked on the SMS permission with Fred. A genuine application that's being like an SMS application, like if there is a proper use case and it's the main use case of that application, you can still submit your application and detailing all what the application, why the application need that permission to the Play Store. So when we didn't remove the SMS permission, it's just for most application, I don't have obviously numbers in my head, is mostly having the SMS authentication, which is a fair point. It's like something that a lot of developers use. And for that, we have the SMS Retriever API. It wasn't maybe the easiest API to use, and that's why we also introduced the SMS User Consent API. It doesn't ask that permission, and it's way friendlier with the user. So for those use cases, just doing the SMS authentication, we have alternatives being there. SMS Retrieval API and SMS User Consent API. For now, after on the case on being a message application, if you detail properly why you need that permission and show proper, I think they may ask a video or photo to explain your use case, that's still being reviewed. So we're not banning that part. We just need more explanation rather than just, I request it, please give it to me.
I think part of that question too was, yeah, but are things going to change in the future? A, hard to predict future, but B, we do keep working on privacy-centric capabilities for the platform because that's increasingly important to users. And so I would think that there's going to be other things in the future where it becomes clear that this is an issue that was affecting users, so developers will need to deal with it. I think that behavior changes and policy changes are inherently a part of that. They're not a very fun part of it, but it's a necessary part to protect the users. Which is why, yeah, pay attention to the Play Store and the policy changes because you do want to know ahead of time. We do roll out these changes ahead of time so that people know and have time to react to them. It's not, yeah, it's not fun to react to, but it is necessary to react to it, and hopefully you have the time to do the right thing for your apps.
Yeah, I would add to that. What I would add to that is a big part of it is to provide a more uniformed way of educating developers and serving users. Going forward, we can only add new platform capabilities on newer versions of Android 11, and future Android platform releases. But what about existing devices? So that in order to provide a more uniform experience both for developers and users, we needed some sort of play policy. And that's one of the motivations behind that. And to Chet's earlier point around giving developers more lead time to learn about what's coming in the pipeline and make necessary code changes and or design changes to their applications. There's a couple of recent examples that we've begun doing based on learnings from previous rollouts of policies such as SMS. For example, location. Recently, we announced background location restrictions for applications, and I guess last month we also announced an update, a pending update on policies around the usage of storage permission on Android 11. So again, all of these pre-announcements are meant to give developers enough heads up and lead time to respond and plan accordingly. And oftentimes Play Store enforcements won't become effective until a later point in time to give us an opportunity to ramp up our operations to respond to developer inquiries. And like I said earlier, for developers, we wanted to be working with developers to give them enough lead time. So.
Okay, cool. I think we have maybe time for one more question because I think I have so many of them. There's so many of them. Well, let me try and see how many we can get to answer. So the first, I'll try and combine a couple. So how long is the review process for apps requesting SMS permissions as a core feature? Yeah, and then a comment around code shrinking. Is it currently supported on dynamic feature models? And what's the plan around that?
I guess for the first question, I think we don't have the right folks here today to directly address the lead time. So I think we're going to skip over providing guidance around that. And advise developers to continue working with the communications channels available. And then maybe we can talk about the second question.
Yeah, so the second question is code shrinking currently supported on dynamic feature modules? And what's the plan around that? Code shrinking, yeah, yes.
To be honest, I don't think one of us here worked on that specifically, but I highly recommend you to ping my colleagues or Wojtek Kalinski or Ben Weiss, both are on Twitter. The person who can ask that can ping me. I will redirect that to my colleagues, and both of them work both on those features. They will be the right persons to answer that.
Okay, so how best can you handle versioning in Room in case of a versioning error? Can the crashes in Crashlytics be made more accurate? So how best can you handle versioning in Room in case of a versioning error? So can the crashes in Crashlytics be made more accurate? I guess he's trying to link Firebase, the Crashlytics reports with versioning in Room, and just seeing how we can link the two of them to have more accurate reports, I guess, from the question, from the reports that he's receiving from the other side.
Seeing my colleague's face as well as mine, I think that's also another question where
Yes.
Something I want to say to the developer community, I felt the same way when I wasn't working at Google. Feels like the developer advocates, we are like the expert, like the one that knows everything. You would be surprised how we do not know all of it. Like me, I have some specific projects where I got a certain expertise, but overall, I'm surprised sometimes how some members of the community are way more knowledge than me on so many areas. And I'm not proud to say, but I don't have shame to say, actually, I don't know. And please do not take us as the best ones. We're really here to help you. But on that one, again, for the person who asked the question, ping me. I will try to find the best person to answer you afterwards.
Okay. So, I guess this one here, Chet, please go.
I would second that. I think sometimes we know the answer. Oftentimes we know the right people to ask. Okay. And in this case, I really like the question. I don't really like the fact that I don't have an answer, but we can find out.
Okay, so I guess the last one, and I think this one will probably touch across all of you or all of us. So this is about beginners. So suggestion for beginners. So two questions. I'm seeing one on the YouTube stream and one here. They're more or less related. So suggestion for beginners. Do you have any suggestions for beginners to start with Android? That is like source references, anything that would help. And what should they focus on? And let me combine that with what advice do you have for a guy starting Android with Java right now?
Have you heard of this thing called Kotlin? So let me go back to the previous question, beginners. So I think a good resource in general for people that are new to an area, whether it's new to the language, the platform, a specific API or whatever, is if there's a code lab, which are sort of always focused on a small area, or even a course, which is usually a much larger thing. That's kind of a nice way to get an overview. So specifically, if you're talking about beginning developers, we just had a new course launch in the last few weeks called Android Basics for Kotlin, I think, or Android Basics in Kotlin. It is available on d.android.com. I forget the URL, but it is specifically for people that are new to both Android as well as to software development. So it's introducing software development concepts, Kotlin concepts, as well as Android APIs piece by piece. And then you sort of build up this general knowledge of all of those as you go. If you already have some Android or development experience in general, then there are other focused courses on, courses or code labs on, building a recycler view app that does the following. It depends on like, what is it you want to learn? And then there's usually a code lab or a course, which I find to be a really helpful way to give you sort of a mental model and overview of how this general area works before you then start diving more deeply into specific articles and sample code.
Okay, cool.
For learning Android with Java, actually, if it's because you already know Java but want to learn Android, it's fine. We have all the previous trainings, code labs, so sure, go ahead and continue using Java until you feel confident enough with Android to switch to Kotlin. If you're new to both Java and Kotlin, give it a try. Maybe you like Kotlin more.
Okay, cool.
Well, the good thing.
Yes, Fred, please. Yes, Fred.
I was going to say that the good thing is there's good interoperability between the two languages. Depending on which one you feel more comfortable with starting, you can always, bring in the other programming language into your project.
Okay, cool. So last one, I guess let me ask the last question is it required to ask foreground location permission first and then background location if the user grants the first one? So does this logic apply to Android too? So he's asking something around foreground location permission and then background location if the user grants one of the first side. Okay.
Yeah. So this foreground location versus background location distinction was introduced in Android 10 last year. So the idea is to give users more control into whether if they don't want to give the app location permissions at all or limit it to just foreground in certain cases. So from a best practice perspective, we typically advise developers to request these permissions incrementally. So applying this high-level best practice to foreground and background location, we typically advise developers to first ask for foreground location permissions, and then as the user continues using the app, then request background in context to give users a chance to understand why the application needs it, and again, like I said earlier, give the user some level of control if they wanted to just limit permissions to foreground. Now in Android 11, given this best practice that I mentioned, Android 11 further makes it a requirement at the platform level by disallowing applications from requesting background and foreground locations together in one API call. If that happens, it would silently ignore it. So something to keep in mind.
Okay, cool. So I guess that's the last, because of time. I think we can spend the whole night here or the whole day here. So we just have to end it here, and maybe we can just say at one point we'd really love to have you guys physically in Nairobi. We'll make that an agenda once the whole of coronavirus ends. And so please, it was a pleasure, I think, from all of us hosting you guys. So it's really a privilege for you guys to even take time out to come and share your knowledge and spend time with us and spend time with the developer community in Africa. So anything you want to say right now, this is the right time for us to finish it. And I want to finish it with a funny face. I'll take a selfie because you're not here. So we'll take a selfie. Burp. Wait, so 3, 2, 1, and Awesome. So, so thank you guys so much. And yeah, so from everyone here, you guys have a good night in Nairobi and have a good day if you're watching us from anywhere else all over the world. And bye.
All right. Thanks.
Bye.
Bye.
Bye. So wait a second, and then the stream is over. Yeah. So, Buddha, Juma. You mentioned